Okay, wow, it's been a while since I've done this. Let's see. We're going to talk about arithmetic sequences and then their sums. So let me first describe what I mean by arithmetic. What does it take to be an arithmetic sequence rather than just some other random sequence like maybe some of the ones we've talked about? In fact, we have been doing some examples of arithmetic. We just didn't call them that before. The defining feature of arithmetic is that there is a common difference between two consecutive terms, okay? And we typically will call that common difference D, okay? So when I say a common difference, I mean, let's take an example, it's probably the easiest way. Say you had 7, 11, 15, 19, and so on. And you look and you say, okay, to 7 I add 4 and I get to 11. And then from 11 I add 4 and I've gotten to 15, and from 15 to 19 I add 4. So yes, we've done examples like this, and now we're going to give them the label that they're arithmetic. They have that common difference, D is equal to 4 here, okay? So, common difference in general. Hey, one second. So I guess I just wanted to find common difference one more time for you. That common difference will equal a term minus its previous term. Okay, so this is a term minus the previous term. Okay, the one directly before it. Okay, and that's, pretty obvious here when we're adding and subtracting, but we'll use something similar when we get to multiplication, and that might be more helpful. All right, I'm going to let you try and find out if the following are arithmetic. So that's the first thing you have to do, decide is it arithmetic or not, and then tell me what that common difference is. So I'm going to pause it, let you try it, and see if we get the same results. Okay, I got D is -5, D is 1/4, and the last example was not arithmetic. So go to the next slide, or I'll give an explanation. Of course, the first one's fairly straightforward. You're subtracting 5 every time. It's pretty easy to see. Just write it down, D equal -5. But the second one was a little harder to see, so I decided to do the test about the difference has to be a term minus the previous term. So I started on the right-hand side, and I said 7/4 minus 3/2, and of course I need a common denominator, and I end up with 1/4 as that answer. Now, yeah, I'm going to get a difference, but is it a common difference? So I have to test the next one, 3/2 minus its previous term, which was 5/4. Go to common denominator, and again you see I got 1/4. And again with the third one, just to be super careful, and I find D is 1/4. Okay? So, and the last one, because the difference is changing, then it's not arithmetic. Now last time we were worried about, what would you do to find an expression for the nth term, and we were sort of trying to see if you guys could come up with the pattern on your own. So we're going to formalize that a little better because, some of us are not as intuitive as the others. So we'll start with the formula. To find an nth term, you're going to use this formula for an arithmetic. The nth term can be found by taking your first term, A1, and adding how many D's, how many common differences do you need to get to the term you're thinking about it. So let me show you something. Let me find a common sequence. Maybe I'll start with this and go to there, there, there. And you can see why we need the n minus 1, because you're starting already at 5, and you've already got that A1 there. So I don't need to add any more D's to have the first term. So that's why for the first time I add 0 D's. It's n minus 1 of them. Okay, does that make sense? We'll work on it. But this is the formula we're going to come back to over and over and over again. It's very helpful in finding a way to write the nth term. When you do this, let's do this one for example. Of course D is 4. Of course A1 is 5. So I'm going to put those things in here and get AN is equal to 5 plus leave your N, put in the D. So that's a good expression, but we don't like it because of course it's not in simplest form. So let's distribute the 4. Don't be off put because the 4 is behind the parentheses. It's the same idea where you distribute. That's a 4n minus 4. So let me make this in simplest form. Now I have 4n plus 1. And what's interesting about this is a great answer for finding the nth term. That's what we want, the simplest form. When you look at this, you say, oh, wait a minute, that looks just like a linear function. And indeed, it is exactly like a linear function. And so you can see that this number right here is taking on the role of a slope. And remember, the graphing is everything is the same, except you just don't connect your dots, okay? You only have the integer values. So it'll be a discrete graph, but it's still, you can talk about a slope. Okay, so that's going to come in handy in some of the next things we do as well, if you think about that slope. All right, I want you to try these two problems on your own. Give this a pause, and we'll come back and check our answers together. I just want you to find a formula for that nth term using that that form for nth term that I gave you. Okay, so I got some nice answers here. I'll just point out, if you want to go on, go. I just want to point out when you have a negative common difference, it's real important to use that parentheses there. You can see how easily that would start to look like minus 3 if you didn't use the parentheses instead of being the times a negative 3. So it's a very important difference. The parentheses will help a lot there. All right, here's a problem with a little bit different setup, but I haven't told you exactly how to do this before, but I think I've told you enough that you might be able to figure it out. So I want you to give it a try. If you're struggling too much, just come on back and we'll run through it together. Okay, let me run through this. I wanted you to think about if I gave you 2 points of this relation, and what I didn't tell you and what I really should have, it was very terrible of me not to have, but I should have told you that this is arithmetic. Okay, once you know that, and I hope you assumed it, then you can say it's linear, and I can find the slope. So how'd I go from 20 to 65? It took me 45. So I went up 45 in how many steps? Well, the steps are over here for the nth term, right? And that took me 9 steps. So how can I go 45 in 9 steps? Same as going 5 places in 1 step. So basically finding a slope between these 2 points where you have an n and an an. Okay? So finding slope is a great way to go here. So I find this here, 5, so I know the common difference. So I remember what my formula is that I usually apply, and I decide to use one of my terms, okay, to help me find, basically the y-intercept, okay, but not quite, so let me go back on that. I need to find a 1, right, because that's what's missing in this formula. I know d, I'm going to leave n the way it is. So when I let n equal 4, then I know a of 4, the 4th term, is 20. So I put that in here on the left, right here, and I use the formula, leave a1 as it is, put n equal 4 minus 1 times the common difference that I found, 5. Work that all out and you find your a1 is 5. So 2 5s going on here, don't get confused. But anyways, I'm going to put that back into the general formula that I had over here, right? So I know a1 now is 5, so I'm up here, n minus 1 times d is 5. And then all I had to do was simplify this, and I get an is 5n, and that's my answer right there. So let me let you try another one. If you got the first one, you probably don't need to do this second one. All right, give this one a try. I want you to find a 20. If you already know the 8th term is 26, a 12 is 42. I'm going to pause it, you should, and we'll come back. All right, I got 820 is 74. So let me explain to you how I got that if you need it. I always like to start with my formula. That's the basic nth term of an arithmetic. And of course I needed that d value for that common difference, so I'll use the slope approach on this and say I went from 26 to 42 in 16 units up, basically. And I did that by going over from 8 to 12, 4 units. So that is a common difference of 4, okay? So I found d is 4. I'm going to plug that back in. I'm letting n equal 8, so I'm going to use this information using one of the points and find a1. So one of the points tells me the term is, the value of the term is 26. I'll find A1 plus, n was 8, and then I do the minus 1 times the 4. I work it out to get A1 is a negative 2. So I put that back into this general formula for AN. I do my simplifying to get it more into that linear form. So here it is in that linear form. And then I figured out that the 20 would give me 74.